of functions? Anybody remember what's the domain of any function? All real numbers, absolutely. So the domain of a function is the set of all real numbers. Okay? And so you start, when we're finding it for a composite, you start with all real numbers, just like we did before, okay? But there's an exception to it because this time we got two different functions that we're dealing with, okay? So, basically, if we're finding the f of g of x, okay? So basically the inside function. Okay? And then once you find the it has to be excluded. And then once you find the inside function and go to do the outside, then that part must be excluded too. So it's like a two-step process. You're going to have two different domains that are, it was after the homework page. With me now? Good. Okay, so to find the domain, you got three steps, okay? So the first step is you find the domain of the inside function. If I have f composed with g, that makes the g of x is my inside function. Do you agree with that one? Okay. And my domain, it's going to start with all reals, but then what questions do we ask ourselves about domains? Is there a fraction? What were the other questions? Is there a radical? Okay, or is there both? Okay, so when we look at g of x, do we have a fraction? Yes, yes, okay. What was the rule when we had a fraction? What did we need to do?
Get rid of the denominator.
Set the, well, not get rid of it, but set the denominator to what? So that it can't equal 0. Because I can't have 0 in the bottom because you can't divide by 0. Would you agree with that one? Okay. Okay. If it was a radical, we set the denominator so that it was greater than or equal to 0. And if it was both, what did we set the denominator to? Just greater than 0, because we couldn't. Remember that? Yes? Hopefully? Yes, good. All right, so x minus 1 cannot be 0, so x cannot be 1. All right? So far, my domain, x can't be 1. You agree with that one?
Yeah.
Good. Thanks. Okay. Now, we need to find the domain from the outside function. Okay? So the outside function means that we have to do the actual f of g. Okay? So that means that if f of x is 1 over x plus 2, I'm going to replace x with my g of x. Do we agree with that? Good? Alex, you with me? Okay, because remember, if I'm substituting my x with all of the g of x. All right? Okay, now let's simplify. So that means I need to multiply by that bottom denominator. So the top becomes x minus 1. And I have to distribute to both. So I'm going to get 4 plus 2x minus 2. And so my composite function is going to be 2x plus 2. Everybody with me on that one? Because I multiplied x minus 1 because that was the bottom of this fraction to make that fraction go. I did because when I did 4 times x minus 1, those are going to cancel, which leaves me with the 4. All right. Okay, so step 3. We're going to evaluate for any exclusions. In other words, we're going to do the domain of the composite. So, do I have a fraction? Yes. So I set 2x plus 2 so that it can't be 0. And now I need to solve for x. Good so far? All right, so 2x equals negative 2. Oops, I should say cannot be negative 2. So x cannot be negative 1. Good? All right, so then both of this one and that one then becomes my domain in that x cannot be negative 1 from the composite function, and then x can't be 1 from the very first original function. Good. Oh, because I'm an idiot and didn't add a 1 in there. Tammy, with me? All right, just couldn't see. Shall we do another example? Sure, love to. Alrighty. First step. Find domain of outside. Okay, so I'm F composed of G and G composed of F. Let's start with F composed of G. So my G of X is 2x plus 3. What's my domain of G of X? Do I have a fraction? Do I have a radical? Do I have both of them? So what's that mean for my domain? Just all reals. So no exclusions from that one. Awesome. Okay. Second step, find my composite. So the f of g of x is going to be the square root, and I replace x with 2x plus 3. That's an easy composite. I like that one. And then the third step, find the domain of the composite. So, do I have a fraction? No. Do I have a radical? Yes. So 2x plus 3 is greater than or equal to 0. And so 2x is greater than or equal to negative 3. So x greater than negative 3/2. Negative 3/2. So my domain's gonna be x is greater than negative 3/2. Good. You don't have, it's all reals, so you can just write, it's assumed all reals except for this one. Okay. All right, now let's do the g of f. So domain outside, now I want to do the square root of x. So do I have a fraction? No. But I have a square root, right? So that means x has to be greater than or equal to 0. Well, that was an easy enough. Good. All right. Let's find our composite. So I'm going to have 2 times the square root of x plus 3. Do I need to simplify anything other than that? No, I'm good just like that. Okay, so to find the domain, do I have a square root? So that means, what do I want to do? Which part do I want to set greater than or equal to 0? Do I need to do anything with the 2 or the 3? When you're finding domain, you only have to deal with what's under the square root. So only look at the radical portion. So it's just going to be, again, x is greater than or equal to 0. Now that's the same, so that means my domain is just x is greater than or equal to 0. Good. All right. Shall we do one more with the rational? Just to practice to do that one, or are you good? Let's do another one. All right. Okay, so f composed of g. So that means my outside, or that should be inside function. Oh, Sorry. Loopy on cough syrup, maybe. Shouldn't say that because I didn't even take any cough syrup today. All right, so what's my inside function? G, absolutely. So, do I have a fraction? Yes. So that means x minus 3 cannot be 0. So x cannot be 3. Because it's just, I can't add this equal, the denominator equaling 0, because you can't divide by 0. So any other number that is in there, all reals, is going to be fine and give me an answer. Except for 3, because then I have 0 in the denominator. Yes? Okay. All right, let's find my composite. So F composite G means that those two x's get replaced with G. So that means I have x plus 2 over x minus 3 minus 5 for the top. Good. And then I have x plus 2 over x minus 3 plus 1 for the bottom. Good. All right, I want to get rid of these fractions, so I'm going to multiply by the denominator. So when I distribute, I get x plus 2 minus 5 times x minus 3 for the top. And then when I distribute on the bottom, I get x plus 2 plus x minus 3. Everybody good? Paris, where did I lose you?
I just don't.
That is what we did Monday when you weren't here.
Yeah. I just don't know where to get.
Okay, so I multiplied by the denominator to clear those fractions out.
Yeah, I get that.
So when I distribute, my x minus 3's cancel each other out, so I'm left with x plus 2. But this is like one whole number, so I have to distribute to the second number too. So then I had negative 5 times x minus 3.
Why is it times the x minus?
Yes? All right, so let's combine like terms, and because I'm going to have x plus 2 minus 5x plus 15 plus x minus 3. And then I get negative 4x plus 17 over 2x minus 1. Did I do that right? Good. All right, so let's find the domain of the composite. I have a fraction, so 2x minus 1 cannot be 0. Yes. So 2x cannot be 1. So x cannot be 1/2. Good. All right, that makes my domain then all real numbers such that x cannot be 3 and x cannot be 1/2. Feel good?